Tonight, we explore how a 70-year-old blueprint for self-replicating machines, Automata, long before the hum of 3D printers or the quiet churn of AI creating its own code, the Hungarian-American polymath John von Neumann asked a question of startling simplicity and profound consequence. Can a machine build a copy of itself? In a series of lectures delivered in 1949, he laid out the theory of self-reproducing automata, a logical framework that sidestepped gears and steel in favor of pure information. His theoretical automaton was less a robot and more a ghost in the machine, a set of rules operating in an environment of simple parts. It was a thought experiment that would become the foundational logic for artificial life, modern robotics, and a future where technology builds itself. The solution von Neumann devised was one of elegant, recursive logic. He broke down his self-replicating entity into three essential components: a universal constructor, automaton A, which could build anything given a blueprint; a copier, automaton B, which could duplicate any blueprint it was given; and a controller, automaton C, to direct the entire operation. The process was a masterful three-step dance. The controller would first direct the copier to duplicate the master blueprint. It would then instruct the constructor to build a new automaton from that fresh copy. Finally, the controller would hand the original blueprint to the newly assembled machine, completing a perfect, independent replica. By introducing the possibility of random error or mutations into the blueprint, von Neumann demonstrated how these machines could not only reproduce, but also evolve, generating complexity from simplicity in a process that mirrored life itself. Today, the legacy of von Neumann's abstract machinery are inescapable. His logic underpins the genetic algorithms that design everything from microchips to pharmaceuticals, and provides the theoretical basis for AI systems that can modify their own source code. The concept of a universal constructor is now a tangible reality in advanced manufacturing and synthetic biology, where cellular machinery is programmed to build novel proteins. Von Neumann's most critical insight, however, may have been about complexity itself. He theorized that only systems above a certain threshold of complexity could produce offspring of equal or greater sophistication. As today's engineers grapple with the scaling laws of large language models and the emergent behaviors of complex systems, they are, in essence, working from a blueprint drafted over 70 years ago, proving that the future of our most advanced technology was first imagined as a purely logical machine.